All right, well, good morning, everyone. Happy Friday. I'm going to admit I've been a little bit provocative with the title of this talk, OpenCosmo and the Evolution of Science Infrastructure. Those of you who know me know I have this habit of taking the theme of the conference and using it as like a Trojan horse to talk about the things that I actually want to talk about. So I am going to be talking about Globus Compute here mostly and the work we're doing at Argonne on OpenCosmo, but like after 5 minutes or so, it's going to transition and who knows what's going to happen after that. We'll find out together. So I really want to start by thanking the team that I work with because I always forget to do this. I work with this amazing team at Argonne. They are all really incredible people who make it a really joy to go into work every single day. So I want to thank them right up front. Some of them you've heard from, some of them you probably know. So what is it that we're actually doing? So we're computational cosmologists. We at Argonne are running extreme scale simulations of the universe. So these are massively parallel distributed jobs. So this, what you're seeing over here, is one of our most recent simulation campaigns, which used basically the entire frontier for 3 weeks. So these are massive runs, and they produce massive quantities of data, right? Petabyte scale data sets. And this becomes a problem for all the reasons that you are probably familiar from your own work, right? Lots of these types of problems are the things that we're all facing every single day, huge quantities of data, custom formats, maybe on different machines. And we want to provide unified interface to this data for researchers who maybe don't care as much about the details of accessing all that data. I'm going to take a moment to just a brief aside here because I think it's great. So this video right here was made by someone that does a bunch of viz on our team, and it made its way onto the internet, onto Instagram. And exactly what happens when these kinds of things gets to the internet happened, which this lovely exchange happened. What does this simulation show? Great question. It shows all the universe center black holes coming together and building a cluster of black holes. No notes. This is my favorite one though. I lost it. Where'd it go? By the 3D map, it actually denies the Big Bang Theory. So you heard it here first. We have denied the Big Bang Theory on Frontier. Not actually. So this video is actually a very small subset of, this is one single rank, right? So I don't know how many ranks, we're running some absurd number of ranks, like 36,000 ranks, something like that. So this is a tiny volume. Whole thing is much larger. Okay, so this is our challenge. And I am going to make a claim that I think most of us would agree with at some level, but is, I want to put a fine point on it because I've been hearing bits and pieces of it since we've been here. Oh, wait, sorry, no, that's the next slide. This is just a brief video of what we have, right? So this is a portal that we have where users can come in, they can request the data that they want in terms that they're familiar with, right? So these are, maybe you're not a cosmologist, that's totally fine. Just know that these are quantities that cosmologists are comfortable with, right? So they can come to our portal, they can ask for types of data that they want, and we go off onto whatever machine that data set happens to be on. And we go and we get that data for them, and somewhere between 2 and 20 minutes later, depending on what the queue looks like at that time, we come back with a data set, and it's awesome. And this is all Globus Compute, right? Front to back, this is Globus Compute. We start with Globus Auth. First thing that we do, user authenticates to our service. And then the first thing that happens, they submit a request, we go via Globus Compute to a small virtual machine, which decides which machine we need to send this to, which facility, which then gets sent to the machine, submitted to the job scheduler via Globus Compute, stored, given back to the user again via Globus Compute. We haven't talked a lot about Globus Flows, but Globus Flows really are the center of what we're doing here. And if you're not using it for your work, you should consider trying them. They're quite nice. So this is the claim that I'm going to make, and I put a little asterisk here, and this is a fill in the blank asterisk. So whatever caveat you're thinking of this statement here, I accept it. Just put it in your mind. What I mean by this, so I was having a conversation with a friend of mine the other day, fellow postdoc at Argonne, never done any distributed computing, and she wanted help because she had just gotten an account on some resources, and she knew I use the resources a ton. And she only had one requirement, right? Her only requirement that she gave me directly was, I need this thing to run in less than an hour. That was it, right? She didn't care. She didn't even know what MPI was. And so the question is, what's the solution to this problem, right? Some people would argue the solution to this problem is we teach more scientists how to do HPC. I don't think that's the solution. I mean, it's part of the solution sometimes, but I think the real solution looks something more like this. So this is something that we're working on. This is a mock. It doesn't actually work like this yet, but we've been building over the last 6 months a library for interacting with our data. It's big, it's robust, it works, it does all of our back-end work, right? And it does it does things you might expect, right? It can filter, it can take random rows, and it can select things, all sorts of stuff. But where we want to go is this. Where we want to go is for a user to just be able to use the exact same API, but have it executing in the back end, right? They don't even know what's going on, right? All they have to know is this is maybe going to take a little bit longer because it's happening on another server, right? This is where we're headed. Like I said, this is a mock. We're not there yet. But where are we headed, I hope? This is where scientists are headed. Where are we as infrastructure-oriented people headed, I hope? So who is not from Globus knows what this is just by looking at it? Do any of you know what this is? So if you don't know what this is, you should. This is, in my opinion, the most significant advancement in computing in the 21st century. It is infrastructure as code, right? It is the ability to just spin up resources where you need them, when you need them, anywhere. You can use this on any cloud computing provider. If you are a person who cares about building infrastructure and you have not played with these types of tools at some point, you should. It will change the way you think about building infrastructure. We can't do this yet, but I like to think that a day is coming. I wrote this, I have 30 seconds, I'll finish this up. I wrote this section of this talk 3 weeks ago. And then last Friday, a call came out to the labs from the DOE, which says the following. The American Science Cloud infrastructure partners will architect, develop, deploy, and maintain production-grade American Science Cloud API that enables access to DOE Office of Science research infrastructure such as these as code, right? The future is code, folks. A day will come, I hope, where building these types of things looks as easy on DOE infrastructure as it does in the cloud, maybe in like 15 years, probably. But the day is coming, so I do encourage you all to try it out. It will make a difference in how you do your infrastructure. And with that, I will call it there. Thank you for your time.